Hello, myself, Professor H.K. Bangale, Department of First Year Engineering, SMD College of Engineering and Research Center, EULA. So I welcome all of you in a video lecture series of Basic Electrical Engineering, which is a course from First Year Engineering. So today in this lecture, we will discuss about the resistance. All of you knows what is the resistance. Resistance is nothing but it is the property of a material which offers the opposition to the flow of the current. Now, the wire resistance we will see. So the resistance of a wire is proportional to the length of the wire. We have the formula R with rho upon A. So according to this equation, resistance is always proportional to the length of the wire. The resistance of a conductor can be found by the formula R equal to rho L upon A, where R is the resistance of the wire, rho is the specific resistance of the conductor, L is the length of the wire, and A is the cross-sectional area of the wire or conductor. Now, there are certain materials that have a specific resistance. So let us see how much is the gauge and how much is the specific resistance of a particular material that we'll see now. The specific resistance rho is of aluminum having a gauge of 17 and its CMA is 2048. So it is 17. So what we have to find? We have to find R for 1000 feet of 18 cube. Now, so the iron, 19 gauge, CMA is 1288, and its rho, the specific resistance is 58. So, like this, different materials exhibit different and different specific resistance. So here R is rho, there is length upon CMA, that is R will be 10.4. 1000 upon 1624, so it is R is equal to 6.4 ohm. So for this R, you will get the value of 6.4 ohm. Now the types of resistance wire. So certain applications employing heating elements, example toaster, requires a wire with greater resistance than common conductors. So more resistance will generate power dissipated as heat without using excessive current. The resistance wire is the name used to describe wires with greater resistance values than copper. Some examples of resistance wire include tungsten, nickel, or alloys like nichrome. Then the liquid and gases can conduct electric charges just as metals can. So in solids like metals, the atoms cannot move among each other. So each atom remains neutral while the drift of the free electrons conducts the charge. So in liquids and gases, the atoms can move among each other. The atoms therefore again gain or lose certain electrons easily, resulting in atoms that are no longer neutral. So the charged atoms are called as ions. Charged atoms are called as ions, and ions are the electrical charge carriers in liquid and gases. While the negative ions is the atom that has an excess number of electrons, and positive ion is an atom that is missing one or more electrons. So it is enough for today. Next time we'll see how the resistance depends on the temperature, that we'll see. Till then, thank you.